Question number 1 is one end of a light inextensible string is attached to a block. The strings makes an angle of theta with the horizontal. The tension in the string is 20 Newton. The string pulls the block along a horizontal surface at a constant speed of 1.5 meter per second for 12 seconds. The work done by tension in the string is 50 J. We have to find the theta. Now say this is the block and the string is making angle of theta. The tension in the string is 20 Newton and the given is work done. You know work done is equal to force into displacement. Force should be parallel to the displacement. So force which is parallel to the movement, to the motion. Definitely that is the horizontal component and that will be (20 cos theta). Why? Because the angle made by string is theta. So this will be 20 cos theta. It means the force is 20 cos theta and the work done is 50 joules times displacement. Now to find the displacement we know the constant speed. Constant speed is just like the average speed. So distance is equal to speed time time. Speed is 1.5 for 12 seconds. 1.5 times 12 is 18 meters. So 50 is equal to 20. Sorry, the distance will be 18. 20 cos theta times 18 repeated हो गया. So cos theta will be equal to 50 times nothing. 50 times 50 divided by 50 divided by 20 times 18. So that is 50 divided by 20 divided by 18, that is 0.13888. So cos theta is equal to 0.13888, whatever. So theta will be cos inverse of this, which is 82.016. So that is 82.016 degrees. Question 3. A particle A moves in a straight line with the constant speed of 10 meter per second. So constant speed of 10 meter per second. This is we are talking about particle A. 2 seconds after A passes a point O on the line, a particle B passes through O, moving along the line in the same direction as A. Particle B has speed 16 meter per second at O and has a constant deceleration of 2 meter per second square. Find expression in terms of t for the displacement from O of each of the particles t seconds after B passes through O. T seconds after B passes through O. Means the starting time starts when the B passes through. So first we talk about particle A. Now for particle A, there is a constant speed, and constant speed is 10 meter per second. And its time will be t plus 2, because when we start t, means t is the time taken by B. So the time taken from A will be 2 seconds more. That will be taken as t plus 2, because it will be taking all the times it will be taking 2 minutes more than B. And we have to find S, because in this case U is 0. S is equal to ut plus half at square, but we don't need this one. If you will apply, obviously this is constant, the start and end same speed, displacement will be, the constant speed is there, acceleration is 0, this expression will become 0. So we can apply the simple formula that distance is equal to, distance will be the displacement, because the particle A as well as the particle B, they are moving on a straight line. Distance and displacement here will be the same thing, and that will be speed times the time, which will be 10t plus 20. But in the case of particle B, the particle B has a different situation. Time taken is t seconds. Initial velocity is 16 meter per second. E is minus 2 meter per second square, and we have to find S in terms of t. So S is equal to 16t plus half into minus 2t square. So that will be 16t minus t square. This is the expression for displacement for B, and this was displacement expression for the displacement of A. This is the first part. Second part is find the distance between them, between the particles when B comes to instantaneous rest. B comes to instantaneous rest means V is equal to 0. And V of B will be ds of B over dt, means the expression of the displacement will be differentiated to find the velocity, which is 16 minus 2t. 16 minus 2t, because speed of B is 0, is equal to 0. That will give us 2t is equal to 16, means t is equal to 8. 16 over 2, which is 8. So when t is equal, means after t seconds, the displacement of B will be 16 into 8 minus 8 square, and that is 64. And S of A will be, the expression was 10t plus 20. 10t plus 20 means 100 meters. So the distance between them will be 100 minus 64, which is 36. Yes, 36 meters. The third part is find the minimum distance between the two particles. The first thing we need to find because they are traveling on the same straight line, distance between the particles, let's minimum. Before finding the minimum, we just need to find the expression which represent that one, because we have the both expressions. So the minimum distance between the particles will be S of A minus, means difference between their expressions. So S of A was 10t plus 20, and minus SB is 16t minus t square. So that will become 10t plus 20 minus 16t plus t square. So that will be t square minus 60 plus 20. Now, this is the displacement or the distance between the two particles. To find the minimum value of this is a quadratic expression. Find the minimum distance, minimum to find minimum value of this one. You know, the turning point will be this one. Definitely the graph will be like this, and it will have a minimum value. So you just have to find the minimum value. We can differentiate this one, and that will give us, because at the turning point the derivative is 0, so that will be 2t minus 6. So 2t minus 6 will be put equal to 0, which will give us t is equal to 6 over 2 3. So minimum value will be, minimum displacement will be at t is equal to 3. So we will substitute this, means to find the minimum value, we will put value of t is equal to 3 in this one. So the minimum distance between them, we have the expression for that. That will be 3 square minus 6 times 3 plus 20. That is 9 minus 18 plus 20. So 9 minus 18 is negative 9 plus 20 is 11 meters. Question number 6. The diagram shows a fixed block of with the horizontal top surface and a surface which is inclined at an angle of theta to the horizontal, where sine theta is equal to 3 over 5. A particle A of mass 0.3 kg rests on the horizontal surface and is attached to one end of the light inextensible string. The string passes over a small smooth pulley P fixed at the edge of the block. The other end of the string is attached to the particle B of the mass 1.5 kg, which rests on the sloping surface of the block. The system is released from rest with the string taut. Given that the block is smooth, find the acceleration of the particle A and the tension in the string. There will be tension T on this side, and from B the tension will be same as the string is taut, the tension would be same. It will be the forward force will be T, backward force no friction is there. T is equal to, and the mass of MA, mass of the particle A is 0.3 kg. So it will be T is equal to 0.3 A. Now let's talk about B. Mass of B 1.5 kg, 15 Newton. It's perpendicular, 15 cos theta, and this will be 15 sin theta. Since the surface is smooth, the block is smooth, it's already given. And both, since they are attached to a string is taut, both particles will have the same acceleration and the same tension will be the string. So here we can see forward force is 15 sine theta, 15 sine theta minus backward, which is t, that is equal to 1.5a. So that is the second equation, 15 sine theta. Yes, 15 sine theta minus t is 1.5a. So solving them simultaneously, t is equal to 0.3a. So it's easy to add these two equations, which will cancel t, and we will left with 15 sine theta is equal to 1.8a. And sine theta, the value of sine theta is given 15 times 3 over 5. So 9 over 1.8 is equal to a. Is equal to 5 meter per second. So the tension will be A is 5. The tension will be 1.5 Newton. For the second part, it is given instead the block is rough, the coefficient of friction is between A and the block is mu, and the coefficient of friction between B and the block is also mu. In the first 3 seconds of the motion, A does not reach B and B does not reach the bottom of the sloping surface. The speed of the particle after 3 seconds is 5 meter per second. Find the acceleration of the particle and the value of mu. So in this case, first we need to have the diagram again. But for acceleration, I think the data is completely given. Why? Because u is 0, v is 5 meter per second, a is to be found, and time is given 3 seconds. We can apply v is equal to u plus at, where v is 5, u is 0, a to be found, and t is 3. So 3a is equal to 5, which will give us a is equal to 5 by 3 meter per second square. Now, as the block is not smooth and it is made up of same surface, mu is same, let's talk about the forces. Here, since this is 0.3, so 3 Newton, this is 1.5, so 15 Newton. The component perpendicular to the surface will be 15 cos theta, and parallel to the surface will be 15 sin theta. There will be a force of reaction because there is coefficient of friction and it's moving. There would be, and there will be R. Tension here and here. 15 sin theta we know is 15 times sin theta was given 3 over 5. 3 over 5, sorry, 5 threes are, so it will be 9 Newton. In the same way, if it's given, then 3 over 5 means if this is theta and this is 3 and this is 5, this will be 4. So cos theta will be 4 over 5. So it means this part will become 15 times 4 over 5. So this is 12 Newton. Now for particle A, T minus 3 mu, because this will be force of friction, and that force of friction is mu r, so r is 3, that is equal to 0.3 times A. We have already calculated 5 by 3, so that will become T minus 3 mu will be equal to, this is 0.1, so 0.5. So we have got one equation from here. For the second equation now, 9 Newton, which is 15 sine theta, or the forward force, minus T and minus mu R. So R is 12 Newton, which is 15 cos theta, and that is equal to MA. M is 1.5 and A is 5 by 3. So here, if we do the cancellation, 3 times 1, 0.5. So we have, why I have written 9? Okay, 9 Newton. Yes, I think no need to write Newton, no problem. Just take the numerical values. So it is 9 minus T minus 12 mu is equal to 2.5. This is the second equation. Minus T minus 12u is equal to 2.5 minus 9. That will be minus T minus 12 mu is equal to minus 6.5, or we can say T plus 12 mu is equal to 6.5. This is the second equation. Let's take T from here. So T is 0.5 plus 3 mu. So there will be, at the place of T, we put this value of T, which is, because we have to find mu only, T, no need to find T here, it's not us. So that will become 0.5 plus 3 mu plus 12 mu is equal to 6.5. This is T, the value of T substituted. So we have now 15, 12 plus 3, 15 mu is equal to 6.5 minus 0.5. So mu is equal to 6 over 15, which is 0.4.